Another two types of electrodes. In that first one, Mercury-Mercurous sulfate electrode, Hg2SO4. It consists of mercury covered with a sparingly soluble Hg2SO4 in contact with H2SO4 or K2SO4, which is source of SO4 minus 2 ions. It consists of mercury covered with sparingly soluble Hg2SO4 in contact with H2SO4 or K2SO4, which is the source of SO4 minus 2 ions. And electrode representation is the Hg liquid, Hg2SO4 solid, SO4 minus 2 aqueous. And the cathode reaction is Hg2SO4 will undergo reduction. So Hg2SO4 plus 2 electron gives rise to 2Hg plus SO4 minus 2. The next equation is E cell is equal to E0 cell minus 0.059 by 2, because the number of electrons are 2, log SO4 minus 2. Hg liquid and Hg2SO4 solid we should not consider. Only aqueous SO4 minus 2 we should consider. And its reduction potential value is 0.616 volts with respect to standard hydrogen electrode. And one more important point is it can be used as a secondary reference electrode, that is Mercury-Mercurous sulfate electrode. And the second type is Mercury-Mercuric sulfate electrode, almost the same, only difference is there it is mercurous sulfate, here it is mercuric sulfate, HgSO4. It also consists of mercury covered with a sparingly soluble HgSO4 in contact with H2SO4 or K2SO4, source of the SO4 minus 2 ions. Electrode reaction, Hg liquid, HgSO4 solid, SO4 minus 2 aqueous. The next equation is same. Cathode reaction is the HgSO4 solid plus 2 electron gives rise to Hg liquid plus SO4 minus 2 aqueous. The next equation is E cell is equal to E0 cell minus 0.0591 by 2 log SO4 minus 2, and this electrode also can be used as a secondary reference electrode. These are the two types of the electrodes. One is Mercury-Mercuric sulfate, another one is Mercury-Mercurous sulfate.